Alright, welcome to the area of a regular polygon, level 2. Now, in this case, our example says this: create a right triangle from the regular polygon below. I really wanted to break this process into steps because whenever you're given, like let's say this regular pentagon, we know it's a regular pentagon because we see all these little tick marks here. 2 tick marks on each side indicates all 5 sides are congruent to each other. And let's say that I call this side 5 centimeters. Well, we know that our formula for the area of a regular polygon will be the area of the polygon is equal to 1/2 the apothem times the perimeter, as we discussed in our level 2 video. Now, in this case, though, you might notice something is missing. We do not, in fact, see the apothem. It is missing, and we don't know what it is. So in regular polygon problems where we're trying to find the area and we don't have the apothem, it gets a little bit trickier. The purpose of this video is I want to show you how you can divide your regular polygon up into multiple triangles and from there create a right triangle, which we'll discuss further in our level 3 video. So let's go ahead and take a look at this pentagon. What I want to do to divide it up into triangles is I want to go here to the center, and I want to draw myself a bold line from the center to each vertice. We know every vertice will be where our 2 lines connect. You can kind of think of them as the joints of the polygon. So I'm going to go ahead and draw this. And if you'll notice, our pentagon has 5 sides. It's going to give us 5 complete triangles. Now, our next step is we want to find out what are the angles formed by these triangles right at the top. So I could find an angle there, an angle there, an angle there. And if you'll notice, to find all of these angles, if you go all the way around, it actually creates a circle. So our method here is I'll just do 360, and I'll always use 360 degrees, divided by, and I'll go ahead and kind of write this right here, the number of sides. And in this case, once again, our number of sides is going to be 1, 2, 3, 4, 5. So I'll do 360 divided by 5. Now, 360 divided by 5 is an even number. It's going to give us 72 degrees. And I can write that in right there. I can write that in right there. And I can even write that in right there. It's each one of these angles. They're all the same due to the fact of the polygon being regular. Now let's go back to our apothem, and I want to put this apothem in a different color, and so let's go ahead with a nice yellow here. So here's our apothem. This is ultimately what we're trying to find, and what do you notice that it does to this triangle right here? Well, the apothem will always cut everything in half. Just remember that, the apothem cuts everything in half. And when it goes down to this base, it's a perpendicular bisector, so it will form a right angle. And so what we should see right here is a very bold right angle. And what I'm always going to have y'all do is take that right angle and draw it right off to the side. Now, for this right angle, we'll put our 90-degree angle. And we know each one of these sides was 5 centimeters. And like I said, the apothem cuts things in half. So we have to ask ourselves, what is half of 5 centimeters? Well, if you were to do 5 divided by 2, let's go ahead and do that. 5 divided by 2. Well, that would equal 2.5. So I can say our base of this right triangle is 2.5. And in this case, our units are centimeters. Now, this brings us to this angle up top. We have to know what that is. Well, see how earlier we found that each one of the angles was 72 degrees? In order to find that angle, we're going to have to do 72 divided by. And once again, what does the apothem do? It cuts things in half. So we'll do 72 divided by 2. Let me undo that. We'll do 72 divided by 2, and that's going to equal 36 degrees. And so I can go ahead and write that 36 degrees in there, very small. And this is, in fact, the right triangle that we want to pull from our regular pentagon. Let's go ahead and look at one more example. Okay, so I'll go ahead and clear all this off. Let me go back to this kind of light blue, more of a teal if you will, and let's write example 2. Now I'm going to kind of abbreviate the problem and I want you to find the right triangle. We should know this, but a right triangle, we know that creates 90 degrees. Now in our last example, we used a regular pentagon. In this one, let's go ahead and use a regular hexagon. And just as a side note, the regular hexagon is going to be the most common problem you'll see when they don't give you the apothem. Now let's go ahead, we'll give it 1 tick mark, 1 tick mark, 1, 1, 1, and 1. We want to indicate that all these sides are congruent to illustrate it's a regular polygon. And I'll go ahead and let's call this side right here, let's call that 10 centimeters. Now if you recall, our goal is to find the apothem, but first we have to do that by finding a right triangle. Let's put our center, and our step 1 is we always want to draw triangles from these vertices to the centers, or the center, my apologies. Okay, so we draw a triangle, and we know that we now have 6 triangles, and if we go all the way around the center, it creates a circle. So what's our magic number? How many degrees are in a circle? Yeah, right, we know it's going to be 360 degrees, divided by the number of sides. In this case, let's see, it's 1, 2, 3, 4, 5, 6. And 360 divided by 6, fortunately, comes out to be 60 degrees. So a very nice even number. We could write that in right there, 60 degrees, 60 degrees, 60 degrees. Let me make that one better. Now, remember, the ultimate goal, though, is we're trying to find a right triangle, and our right triangle will be created by drawing the, what's that fancy A word again? By finding our apothem. And we know that when we drop our apothem from the center to the midpoint of the base, it divides that into 2 pieces, and it forms a right angle. And we're going to take this right triangle, and we're going to draw it over here, completely separate. And this time I'll draw it a lot larger, so it might be a little bit nicer and neater to see. I'll put my right angle, and we'll wait a second. If this side is 10, well, we know that if the apothem divides things by 2, 10 divided by 2 would give us 5. And I'll go ahead and write that right there. We know our base of our right triangle is 5 centimeters. The last thing that we're going to need is we want to come up here and put an arc. And if you'll recall, each one of these central angles is 60 degrees. And our apothem, what does it do again? Cuts things in half. That's right. So we can take that 60 degrees divided by 2, and that's going to give us 30. And so it turns out that our top angle here will be 30 degrees. Now one last time, I really do want to illustrate, all of this is to find this right triangle, but ultimately we're doing that to find this side of the right triangle, and let's label that X, and let's go ahead and write the apothem. Go ahead and practice these 5 examples, pulling the right triangles from these different regular polygons, and I'll see y'all in level 3.